Guys, welcome back to the channel. My name is Ruv, and in today's video I'm going to show you what a Gaussian splatting model looks like. We're going to delve into the model and what different parameters the model has, and this will give you a detailed overview of what the model looks like. We will also talk about spherical harmonics and how different orders of spherical harmonics represent different information. So stay tuned until the end of the video. So here it is, guys. I have a model that I trained for Gaussian splatting. So this is a model. It's essentially, as we've told you before, the Gaussian splatting model is a ply file with all the information in it. Essentially, Gaussian splats are a bunch of 3D Gaussians in the space, and those Gaussians have their own parameters. All that information is stored in this ply file. So let me show you this ply file over here. There we go. Right here. This is what that ply file is. It's around a 260 MB file, and this ply file contains all the information. So let's see what this ply file looks like. So first, over here I'm gonna use this library to read this ply file. So I have read in this ply file into the ply data, and when I print this ply data, it has all these parameters: x, y, z, nx, ny, nz, fdc, fdc1, fdc2, frest from 0 till all the way till 44. Then we have opacity, scale, rotation. These are all the parameters of the Gaussian. In the Gaussian splatting introductory video, we covered what these parameters represent and what all parameters are there in Gaussian splats. If you're interested, you can go watch that video. It will be very helpful for you. But let's see, for example, here when I try to print the x, these are all the axes, right? So let's see the shape of this. There's around there's around 1,075,170 Gaussians in this file, right? So that's how many Gaussians are being used to represent the scene. Over here is all the x components. So each Gaussian has an x, y, z, and here I've printed the x for the Gaussians. So one by one, if we go over all these parameters, x, y, and z represent the 3D location, the x, y, z of the Gaussians in the 3D space. So each Gaussian ball has an x, y, z in the 3D space. That's the information here. Nx, ny, and nz are the normals. fdc0, fdc1, and fdc2. Now this part is the most important. We'll come to this after. This is related to spherical harmonics. Let's just go over first the other things. The opacity. So opacity is again the ability of the Gaussian to obstruct light. So for example, if the opacity is high, that means that Gaussian is going to add a lot towards the final rendering. In other words, if there's light going through and opacity is high, this Gaussian is going to block the light and it won't really pass through. If opacity is low, the light will pass through, and that means if there is a Gaussian behind it, you will be able to see it. That's what opacity defines. Scale, how big the Gaussian is. Scale, essentially, the bigger the scale, the scaled up the Gaussian is. Smaller the scale, the smaller the Gaussian is. And we have scale in for 0, 1, and 2 for defining scale in x, y, and z direction. So there's the scale in all 3 dimensions. Rotations, how the Gaussian is rotated in the 3D space. So it's 0, 1, 2, 3. It's a quaternion, so it's of length 4 to determine or to demonstrate the full rotation of that particular Gaussian. Now let's go to what the features rest and feature DC look like. What are these? FDC and FRest. So these are feature DC and feature rest. They are essentially all the spherical harmonics. And essentially this is what defines the color of the Gaussian. Let me show you. So here we had feature, so if we go here, we had feature DC 0, 1 and 2, and then we had feature rest from 0 up until feature rest 44, right? So we have 3 feature DCs and 45 feature rests. Okay, so let's see how they are broken down. So we have, let me go to the pointer here. So we have all the features drawn out here. So the first, for each of the color, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. For each color, we have 16 spherical harmonics. So we have 16 for R, 16 for G, and 16 for B. In total, 48. And if you combine feature rest and feature DC, there's 48 different parameters, different values. The feature DC defines the 0th order. So this is order number 0. So this, and this, they are feature DC 0, 1, and 2. And then rest is feature rest. So all the way from feature rest 0 to feature 44, you'll have these 45 total spherical harmonics. 0th order spherical harmonic defines the maximum contribution to the color. The higher order spherical harmonics are more towards high frequency components. So the majority of the color will be defined by the 0th order, and then the higher order spherical harmonics will add in high frequency information into that particular rendering of yours. So for example, these would play a part when you're looking at an image from different viewpoints, an object from different angles. Lighting will change, reflections will change, and that's where some of these high order spherical harmonics will play a role. So that will give you an understanding, hopefully, how these features DC and feature rest are organized and how to interpret them. When I was working through this, it took me some time to understand that, and I had to seek some help, and this is how I was explained. So I thought making a video on this probably will be helpful. So let me just show you a few more. So see, we have printed out rotation, we printed out feature rest, feature DC, we can print out the opacity as well here. And see, all the different parameters are in here. All of it is stored in that file, and this is what you're using when you're rendering using a trained Gaussian model. So that's it, guys. I hope this video was helpful. I hope this video gave you some understanding of what 3D Gaussian splats look like, what a model looks like, and how all the information is stored in the model. I also gave you some overview of spherical harmonics, how the 0th, 1st, 2nd, and 3rd order spherical harmonics affect the final output with regards to the RGB rendering. Thanks a lot for watching, guys. If you like this video, please hit the like button, subscribe to the channel, and hit that bell icon so you are notified about any new update video we post. Again, thanks for watching, and I'll see you in the next video.